Hello students, in this video we discuss s orbital shape and radial probability distribution curves. For s orbital, azimuthal quantum number value L is equal to 0. Magnetic quantum number is also 0. Number of suborbitals have to calculate by using 2L plus 1 formula. If the L is equal to 0, then the number of suborbitals is equal to 1. So that is M is equal to 0. Maximum electrons in suborbitals is equal to 2 into 2L plus 1 or 4L plus 2. L is equal to 0 for s orbital. So that is 2. So maximum electrons in suborbitals, s suborbital is equal to s orbital is 2 electrons. S orbital shape is spherical. Spherical structure. The electron density is concentrated along the axis as well as between the axes. The number of nodal planes is equal to azimuthal quantum number. For s orbital, azimuthal quantum number is 0. There is no nodal plane for s orbital. Nodal plane means where the electron probability is 0. So the electron density is concentrated along and between the axes. So that's why the number of nodal planes for s orbital is equal to 0. A radial probability distribution curves. Radial probability distribution curves. A radial probability is also called as a D function. The D function is 4 pi r square dr psi square. Here the dr is equal to distance between two adjacent spheres. This is the first shell and the second shell. The distance from here to here is indicated that dr. Here how to draw the graph between D function, distribution function, and the radius. Now take the S1s orbital. The x-axis contains the radius, distance from the nucleus, and here the D function. In this axis, I have to take only 4 pi r square psi square value how to consider. Nearer to the nucleus, the electron probability value is equal to 0. From nucleus to electrons revolve around the nucleus. The electron density nearer to the nucleus is 0. The distance is increases from the nucleus. Electron density is also increases up to the maximum. Then the value is decreases. For 1s orbital, the electron density is the maximum is at 0.53 angstrom units distance. And how to take the 2s orbital. 2s orbital, this is the nucleus, first shell and the second shell. The electron density nearer to the nucleus is 0. Then the value is increases up to the maximum, then decreases. That can be reaches to the 0, that can be touches to the x-axis. Again, the value is increases up to the maximum, then decreases. For 2s orbitals, the electron maximum is present in two places. This is the first maximum and this one is the second maximum. The first maxima is present at 0.53 angstrom units distance and the second maxima is there at 2.6 angstrom units distance. Between these two contain nodal region. That region is present between 1.1 angstrom units distance from the nucleus. So here the question is there, the maximum, two maximas are there. One maxima is present at 0.53 distance and the other maxima is there at 2.6 distance. How much difference is there between first maxima and second maxima? First maxima and second maxima distance are asked. Distance between second maxima and first maxima is 2.6 minus 0.53. So the distance is 2.07 angstrom units. So from this point to this point distance is 2.07 distance. And whatever the 0 is there, that is called as a nodal region. So this region is the nodal region. For 3s orbital, this is the first peak, touches to the 0. Next is also touches to the 0. The next one is the maximum peak. 1s orbital, 2s orbital, third shell, 3s orbital. Here the radius and d function. Here also the same radius and d function. Here the nodal planes, the number of peaks is calculated. Nodal regions, number of peaks, and spherical node, radial node, that is also called as a nodal region. Number of peaks is equal to n minus L form. Spherical nodes, radial nodes are the nodal region formula n minus L minus 1 form. Consider the 1s orbital. N value is the 1 minus 0 equal to 1. One peak is there for s orbital. Nodal region 1 minus 0 minus 1 is equal to 0. There is no nodal region for this 1s orbital. 2s orbital. 2 minus 0 equal to 2 peaks. 2s orbital, the number of peaks are 2. Nodal regions 2 minus 0 minus 1. One nodal region is there. This is the nodal region. For 3s orbital, 3 minus 0 equal to 3. The number of peaks are 3. 1, 2, 3 peaks. And number of nodal regions 3 minus 0 minus 1 equal to 2. 2 nodal regions. This is the one nodal region and this is also another nodal region. 2 nodal regions are there for 3s orbital. Thank you. For more updates, please subscribe my channel.